Hello, my chickens. In this video, you will learn how to graph exponential functions. My name is Katya Sieberson. I'm the inventor of the Sieberson method, a scientifically proven way to learn anything fast, especially how to graph exponential functions. Again, this video is a lot more for my upper IC chickens, but if you're preparing for the SAT or the ACT, all good. If you want to know how to graph exponential functions, it's cool with me. But first, we need to take a look at a classical formula for an exponential function. Exponential function, f of x, again, usually we just mentally replace it with y, and then it consists of three components, a, b, and x. Why do we call it an exponential function? Because your variable or your x is an exponent. That's why it's an exponential function. A is your initial value. B is going to be something that's the most important about graphing. This is going to be your rate, and x is going to be your variable. So let me again point you guys down right here. And let's say, I'm just going to use y. Our initial value was $200. That's our A. And then we invested it at a rate of 10%. Our rate is then going to be 1.1. So this is going to be our B. And then X is going to be our exponent. What do you think is the best way to graph this function? Well, you're going to think about your boomerang again. Remember how we used, if you watched the video about logarithm, you probably remember how we used the boomerang to remember how to graph a log. Here, we're going to remember our boomerang again, but we're going to flip it a little bit differently. So we are going to first consider whether this is exponential growth or whether this is exponential decay. And this is because your B is your rate. This is greater than 1. If your B is greater than 1, then you're going to have growth. If your B is less than 1, then you're going to have decay. That is very, very important for you guys to remember. So now, how do we graph them? On the coordinate plane, in our situation, we have an exponential growth. So our function, our boomerang, is going to look something like this. It is growing exponentially. This is your x and this is your y. This is your exponential growth. So now I'm going to demonstrate a few examples. So this is exactly what it would look like. Now, I'm going to go to Desmos again. And this is an example of a function that is similar to the one that I showed before, but here your b is less than 1. Here your b is 0.3. So now let's imagine that instead of investing something at 10% at a positive rate, let's say we invested something at negative rate. What would the function then look like? We would flip it over through the y-axis. So the function would then look like this. This is when your b is less than 1. Don't think it's less than 0. It has to be less than 1. So here we would have f of x is equal to 200 times 0.9 to the x power. Here we're going to have 200 times 1.1 to the x power. This one is exponential growth. This one is exponential decay. What it means is that as your x is going up, your y is going down, and eventually it's going to reach 0. Sometimes, it's not very likely, but sometimes they could ask you for a negative function. Then you're just going to have everything at the bottom here. So if they gave you a negative 2 times 1.1 to the x power, then you're going to make it look like this because it is growth, but it starts at the negative. And if they gave you negative 2 times 0.9 to the x, you're going to write it in at the bottom here, but it's going to be dk. So as x is going up, y is going to be moving down. So this is what it would look like. I hope this video helped you guys to remember how to navigate graphing exponential functions. They have two main components. They have the rate and they have that exponent in the variable. So that variable in the exponent, the other way around. And that's how you can recognize whether something is exponential growth. So as x is going up, y is going to be going up. Or exponential decay means x is going up and then y is going down. I'll see you in the next video. You'll learn how to graph another function for ISEE.